In our previous lecture, we mentioned the importance of sampling in statistics. If you recall, our goal was to collect data from a sample to try and make inferences about the population as a whole. Now, for our sample to give an accurate picture of the population as a whole, we must ensure that our sample is representative of the population. As an example, imagine I wanted to get a sense as to whether or not adult Americans thought that college tuition was too high. Why might using a sample consisting of people in this class not be a good representation for the population as a whole? So we will consider questions like this in today's lecture. Now, before we discuss how to properly select a sample, we'll first discuss how to sample badly. Sampling improperly typically results in data that is not representative of the population as a whole, and thus is not useful for making inferences about the population. To construct samples that are representative of the population, we will use what's called a simple random sample. A simple random sample is one that is chosen in a way that eliminates preference for certain individuals and outcomes. Finally, we will discuss the actual process for selecting a simple random sample using a table of random digits. Random digits are exactly what they sound like. Now, what distinguishes a good sampling method from a bad one is the presence of bias. Biased sampling methods systematically favor certain outcomes. Now, two common sampling methods that are typically biased are convenience samples and voluntary response samples. In a convenience sample, the researcher constructs the sample by choosing the individuals from the population that are easiest to reach. In a voluntary response sample, the individuals themselves decide whether or not they will be a part of the sample. Why do you think these sampling methods might be biased? For instance, suppose I wanted to get a sense as to who the American voting population currently favors for our next president. Well, I might either asking the individuals that are easiest to reach, or letting the individuals themselves decide whether or not they respond, produce a sample that is not representative of the population as a whole. Let's take a look at an example from your book. Ann Landers once asked the readers of her advice column, if you had to do it over again, would you have children? She received nearly 10,000 responses, with almost 70% saying no. Can it be true that 70% of parents regret having children? Now, in this case, it's unlikely because this is a voluntary response sample. People who feel strongly about an issue, particularly people with strong negative feelings, are more likely to take the trouble to respond. Ann Landers' results are strongly biased. The percentage of parents who would not have children again is much higher in her sample than in the population of all parents. On August 24, 2011, Abigail Van Buren revisited this question in her column, Dear Abby. A reader asked, many years ago an advice columnist posed the question to her readers, if you had to do it over again, would you still have children? I'm wondering when the information was collected and what the results of the inquiry were, and if you asked the same question today, what the majority of your readers would answer. Ms. Van Buren responded, the results were considered shocking at the time because the majority of responders said that they would not have children if they had to do it over again. I'm printing your question because it will be interesting to see if feelings have changed over intervening years. In October 2011, Ms. Van Buren wrote that this time the majority of respondents said that they would have children again. This is encouraging, but this was again a write-in poll, which is a voluntary response sample. Now, what creates bias in convenience samples and voluntary response samples is personal choice. Recall, in a convenience sample, it is the researcher who decides which individuals will be a part of the sample. In a voluntary response sample, it is the individuals who decide. To eliminate the bias, what we must do is remove this element of choice. and this is what a simple random sample aims to do. A simple random sample of size n is a sample in which every sample of size n is equally likely to be chosen. In particular, every individual in the population has an equal chance of being chosen, and every group of n individuals is equally likely to appear together. Now you try one. There are 20 students in my class. They sit in assigned seats consisting of 4 rows of 5 students each. I want to take a simple random sample consisting of 4 students. To do this, I select a single student from each row as follows. I write the numbers 1 to 5 on slips of paper. I mix the slips of paper in a hat, and then I draw one at random. I count this number of seats in from the left in the first row and select a student in this seat. For example, if the number selected is 3, I would select the third student in from the left in the first row. So I'll repeat this process for all 4 rows, giving a sample of size 4. Now every student in the class has a 1 in 5 chance of being selected when I come to their row. Thus, every student has the same chance of being selected. Is this sample a simple random sample? So pause the video and unpause when you're ready for the answer. This is not a simple random sample, as every sample of size 4 is not equally likely to be chosen. In particular, the students in the first row have no chance of appearing together using this sampling method. So let's discuss how one actually selects a simple random sample. Now typically this will be done with a computer in practice, but we can emulate the process for all samples by using a table of random digits. A table of random digits can be found in Table A in the appendix. A table of random digits is a string of the digits 0 through 9 with the following 2 properties. First, each entry in the table is equally likely to be any of the 10 digits 0 through 9. And second, the entries are independent of each other. In particular, the first digit in the string is equally likely to be any of the digits 0 through 9. And if the first digit was 1, say, then the second digit is still equally likely to be any of the digits 0 through 9. In other words, knowledge of the first digit has no bearing on what the entry in the second digit is. Now that we know what a table of random digits is, we can finally select a simple random sample. First, give each member of the population a numerical label of the exact same length. Second, if we're using a table, we'll read consecutive groups of digits of the appropriate length from a table of random digits. Like we said, we could use a computer to do this for us as well. Let's do an example together where we select a simple random sample. Below is a population of 28 hotels. We will select a simple random sample of 4 of them. Now because there are 28 individuals in our population, and 28 is a 2-digit number, we will give each individual a numerical label of 2. Notice how hotels 1 through 9 are also given labels of length 2 by placing a 0 before each number. Using the random digits below, we'll start by looking at the strings of length 2. In this case, the first is 69, the second is 05, the third is 16, and so on. Starting from the left, we will look for the strings of length 2 that match labels for the individuals. Once we've found 4 matches, we'll have our simple random sample. The first is 69, which doesn't match any of our labels. 05 matches Beach Castle. This will be the first member of our simple random sample. 16 matches the Radisson. This will be the second member of our simple random sample. 48 doesn't match any of our labels. 17 matches Ramada. This will be our third member. 87 doesn't match any of our labels. What will the fourth member of our simple random sample be? Now typically we don't want an individual to appear twice in a sample, so although 17 appears more than once, Ramada will only be included one time. Going through the remainder of the list, we see that 20 is the last match, so C Club is the last member of our sample. In conclusion, our simple random sample of 4 hotels will be Beach Castle, Radisson, Ramada, and C Club. Now instead of using a table, we could have used a computer to generate our random numbers. There are several free resources for this on the internet, in particular randomizer.org. Now you try one. To assess how its teaching assistants are performing, the statistics department at a large university randomly selects 3 of its teaching assistants each week and sends a faculty member to visit their class. The current list of 20 teaching assistants is given below. Use either software or Table A at line 116 to choose 3 to be visited this week. Remember to begin by labeling the teachings from 01 to 20. In case you don't have your book with you, this is line 116 of Table A. So pause the video and unpause when you're ready for the answer. In this case, our simple random sample will be from individual 3, 10, and 14. In closing, let's discuss some sources of error when sampling. Undercoverage is a type of error that occurs when some groups in the population are left out of the process of choosing the sample. This type of error can be reduced by choosing a simple random sample. Non-response is a type of error that occurs when an individual chosen for the sample can't be contacted or refuses to participate. Both of these sources of error leads to bias. Finally, a factor you may not have considered is the wording of the questions asked in a sample survey. This is the most important influence on the answers given in a sample survey.